Go left.
Why'd I take Mahomes?
I'm down like a month for the best. I know.
All right. Here we go. Our job, and I apologize for the copy, it's just not all that great. But we're just gonna do our very best here. So our job, if you look at the graphs that are there, we're doing a matching exercise. We're gonna match the table of values to the graph to the equation. So you got graphs, you got equations, and you got charts over here. We're gonna do some matching.
Do you have an extra packet?
Where is yours?
Kind of house.
I don't know, back there, that's, do all the sick kids have theirs now? I think Tim is here.
Oh, got it.
Okay, now, Timmy, you need to bring your own.
Yes,
now,
yes,
okay?
I know. I think it's from when I was studying with it.
You were studying.
No, like my whole folder that I have.
All right. So, some of this you can just tell because notice that all the shapes you have are either lines or parabolas, right? So the equations will either be linear or quadratic. So when you look at equation K, for example, maybe a K, that is going to be a parabola opening down, right? Oh no, up. Up. I can't see. Up, right? I wear glasses for my eyes. That's a parabola opening up. And what about Y? Y is also not Y, M. M is also a parabola opening up, because if you FOILed it out, it'd be x squared. But Q is a line. So you can tell by just looking at the equations some basic shapes. All right, so how do you want to go about this? Let's look at chart number 1. Can you tell me what's happening to the x values? Going up by the x's. The x's are going up by 2, and the y's are all going up by 4. So aren't the y's double the x's?
No, but then look.
You guys 9 and 12.
Yeah, it goes 9 and 12 instead of 15.
Yeah, but then it's 24 and
Oh, I see. But they're going up by 3, but then the y's are going up by 6. So the pattern continues.
Oh, gotcha.
Even though the numbers are, you see what I'm saying?
Yeah, I do.
Okay. So whatever's happening to the x's, y is doubling that, right? So can we find, first of all, do you think that's a linear relationship or a parabola? Do you think that's a line or a parabola? That's linear, right? And with a slope of 2? All right, so can we find that? These pictures are so hard to read. We're finding the equation that goes with, or finding the picture that goes with our equation y equals 2x. So we know it's equation Q. We're just trying to figure out which graph it is. And it's either A or B or D or G. It's one of those. So it's not G.
I like
I can't even read the numbers in A, so I don't know. Do you think it's A?
It's -214 by -36. I don't think that'll be.
no, it's like not gonna do it for us.
Well, I don't know.
So the Y's are going, wait, what did you say? Well, watch your scale though, because if your scale is, like in that first one, you said my X's were going from -214.
That's the first set.
Yeah, those are X's. So they're going from -214. So how many hash marks are in there? It looks like they might all be worth 2. So you need to pay attention to that because it's hash marked in increments of 2.
7.
Yeah,
There's 6 or 7.
yeah. 6 or 7. So that's so, and then your Y's are from -4 to 36, which means, so it's about 8 or 9. So every one of these is worth 4, and every one of these is worth 2. So does it look like it's going over 1, up 1? Because that would be a right slope. Over 2, up 4. This is 2, this is 4. This is 2, this is 4.
How would it happen?
That looks like the most. That looks like the most.
Yeah. I don't want to spend a lot of time on this, but you do, when you're interpreting the graph, you guys, and this is true on your calculator, however you set up your window. On graph A, they tell us that our X's are labeled from -2 to 14. So each step you take in the X direction is worth 2. But the Y's are from -4 to 36. So each step you take is worth 4. So it looks like on the picture that you're going over 1, up 1, but you're really going over 2, up 4. You see what I'm saying? Because of the scale change. So pay attention to that. There is one more thing I want you to notice though. I'd like you to look at table 2. What's happening to the X's? They're going up by 1, right? Okay, let's look at the Y's. The first one goes up by 1, then it goes up by 3, then 5, then 7, then 9. This is not linear, because if it's linear, it keeps going up by the same amount. So that is a quadratic pattern. That's going to be an x squared equation. Number 2 will be an x squared equation because you're not going up by the same amount. Now let's look at table 3. What's happening to the x's? They're going up by 2. What's happening to the y's? They're going up by 6. So that is linear with a slope of 3. Right? 6 over 2?
Yeah.
So that one is linear with a slope of 3. Okay, let's look at the last one. Your x's are going up by 1. What's happening to your y's? Well, they're going down, that's fine. By 3, and then 5, and then 7, and 9. That is not linear, that is quadratic. Quadratic. When your y's keep changing by the same amount, like 3, then 5, then 7, then 9, that should prove that's a quadratic pattern. Okay? So what makes it linear? X's and y's change by the same amount. What makes it quadratic? X's change by the same amount, but y's change by an increasing or decreasing amount, right? 3579. All right, let's go to number 20, comparing cakes. Suppose to celebrate Cooper's birthday yesterday, I went to the bakery, I was gonna buy a cake. And they have two kinds of cakes. They have a 9x13 cake, and they have an 8-inch round diameter. And they cost the same. So what's the question I ask myself as I become a good consumer, standing there at the bakery counter, what do I wanna know? How do I get the most for my money, right? So how would I possibly calculate that?
See which is bigger.
And what do you mean by bigger, Jimmy?
Which cake is a greater area.
Not area, volume, right? Because when you eat a piece of cake, you're eating that three-dimensional thing, right? So yes, we want to compare the volumes. So, tell me about the volume of that guy. The 9x13. Called a sheet cake, right? You know, you've seen it before, little rectangular cake, all nicely decorated. How do I find its volume? Length times width times height. So 9 times 13. Now wait a minute. What do I know about its height?
It's double the,
No.
No, it's not.
no, literally,
You know it.
it's double the twice the rectangular.
So yeah, the round one is double the rectangular one. So what do I know about the rectangular one?
So it's just X, 2X, X.
I could do that. I think I'd rather pick a number. How thick do you think one of those cakes is?
6 inch.
4 inches. Like 1 or 2?
Say maybe 2 inches. You guys, we need some help here at the ruler. We need some help. Now, remember, that number is completely made up. We're just estimating that cake is 2 inches tall. So what would the volume be? How much cake am I gonna get?
234.
Yep, 234 cubic inches. Now, what about the round cake? Now, keep in mind that if the flat cake is 2 inches thick, then this one's gonna be 4 inches thick.
Yeah. Yep.
All right, so how do I find the volume of that? That's your layer cake, your standard old basic layer cake. What shape is that, a layer cake? Well, it's three-dimensional.
It's like a rectangular prism.
A
cylinder.
That cake is not.
The circular
A
one?
circular.
It's a cylinder.
Yeah, cylinder.
So it's a cylinder. How do I find the volume of a cylinder?
You do the 2 circles.
Circle times
Close. Pi r squared h.
Who made pilots?
So what's my radius of my round cake?
4.
4. And the height is also 4?
Correct.
So let's find the volume.
No one knows the actual. That's actually right. Because no one's gonna calculate this.
Now, I know what some of you are thinking. You're thinking, wait a minute, you just made up that the one was 2 and the other one was 4. But keep in mind, all I'm doing here is comparing. I'm comparing. I don't need to know exactly how big each cake is. I don't know how big each cake is because I don't know how tall they are. But I'm comparing them. So no matter what, if the round one is twice as tall as the rectangular one, the rectangular one's gonna be bigger. Every time. So you could choose different numbers if you wanted, go ahead. But if we have that relationship where this is half of this height, then this one's gonna be bigger every time. Okay? So, I'm gonna buy your rectangular cake. Unless the round one looks prettier. Alright, number 21, a garden shop sells 12 by 12 squares for the same price as 13-inch rounds. If all the stepping stones are the same thickness, which option gives the most rock for the money? Kind of the same question, same setup. They're all the same thickness, so I'll just call it 1. Do I want volume again? What do I want this time? Okay, why would I buy garden rock? Why would I go to the store and buy stepping stones? Like, what am I trying to do? To put down and step on, right? So what am I interested in? If I have to, if I'm gonna put rock on this aisle right here, I wanna get as few rocks as I can. I want area, right? Aren't I covering the area?
Yeah.
Surface area.
I'm not stacking them, I'm not doing volume, I am finding the area. So what is the area of your 12 by 12?
144 inches.
So that would be 144 square inches.
Thanks, Brandon.
Same issue, by the way.
What is the area of the 13-inch round? And that means 13-inch diameter. What's that?
6.5.
Pi r squared? Oh man, I got 132.78. So the round ones might look a lot cooler, but I'm gonna need a whole bunch more of those, right? To cover the same amount of ground. All right, 22, here we go. This first section is just full of weird random problems. All of which you have to be able to do on your own, so pay attention. All right. Drops the smoke bomb. Free fall is 16 squared. 70 feet. 18 seconds. How long will it take the bomb to fall 180 feet?
Okay.
Plug in, very good, so 180.
It's on my 16%, then you can do.
And then you square, then you square 2 by something.
Whatever that is. And then you square root it. How long will it take? About 3.35 seconds. If the smoke bomb is in free fall for 12.5 seconds, how high was the airplane when the smoke bomb was dropped?
So put in routine and.
Yep.
Drop right over here.
So 16 times 12.5 squared. Did you get 2,500?
Yep.
Yeah.
All right, that was easy.
Yeah.
All right, number 23, we'll see who was paying attention a minute ago. All find an algebraic model, that would be an equation like this, that's an algebraic model. So can you find, we're on problem 22, or 23, we did a physics experiment. Notice what's happening to the x's, or the t's, what's happening to the t's.
We're on up one.
All right, what's happening to the y's?
Increasing.
Stupid problem.
Good problem. Gotta figure out.
That's gross.
Please don't just sit around waiting for somebody else to come up with the answer.
Oh, I didn't even know.
No consistent.
Let me try again. Try again. I think there is a difference in the Y's. I mean, the same difference in the Y's. Aren't the Y's all going up by the same amount?
No.
Or no, but I mean, they're increasing by the same amount. So,
Really? I don't think so.
unless I did my arithmetic
I
wrong.
got 1.2, 3.6. 4.2.
Okay, so this went up by 1.2. This went up by 3.6. This
They're
went
not,
up
they're
by
not.
6.
6.
This went up by 8.4.
11.2. Wait.
She's like, nope.
Wait, no, 1.8. 1.8.
Is it 3
So hard.
Okay, you guys, a minute ago, we had something that looked like this. Where we were going up by 3, and then by 5, and then by 7, right? These are each increasing by 2.
Yes.
What are these each increasing by? 2.4. Yeah, this is exactly the same thing that was happening over there. Your Y's are changing by an increasing amount, and that increasing amount is constant, 2.4 more each time.
Oh.
That is what it means to be quadratic, okay? Now, you can either play around with it, you know it's gonna be y equals something x squared, so you can play around with it if you want, or you can go to your calculator, stat, edit, and put those points in. So the x's are 0, 1, 2, 3, 4, 5. And the y's are 0, 1.2, 10, 8, 9, 8.
No.
And then go to stat, calc, quadratic regression, because you figured out this was quadratic, so you know which button to press. And your equation is 1.2 x squared.
Wait, what's...
So you go to stat, here's the stat, and then you press edit, that's when you put in all your numbers.
Is L2
L1 is the X's, L2 is the Y's.
Is that,
What?
is that if you didn't figure out 1.2, like if you go the other way?
That's your equation. Now, you might have been able to tell that from the very first point. Where's my paper here? The very first point, well, the second point is 1 comma 1.2. And that means, I knew I had an equation that looks like this, Alden. It was quadratic. And since, when I put in 1, I have to get 1.2, it just makes sense that I'm multiplying by 1.2. But here's my point, you guys. The calculator's gonna do you no good unless you have already figured out it's a quadratic relationship. Because when you go to stat calc, it gives you about 50 options. And if you don't know which option to pick, then you're kind of stymied. So, how did we know it was quadratic? We looked at the x's, and they were all going up by 1. Then we looked at our y's, and they were not going up by the same amount, but the amounts were increasing by the same amount. And that's what it means to be quadratic. Okay?
Yeah.
All right. One more of these crazy word problems. We'll do some easy, just because.
Yeah.
Yeah.
So after you put in the points into the graph, what do you do?
Go back to stat, calc, and choose the regression that you want, which is quadratic.
Quadratic.
Because you have figured out that it's quadratic.
And then after that, it just is.
And it should spit this out.
Oh. Here's the.
Yeah, you gotta have the right points in there. If you don't have the right points in, obviously it's not going to work. Okay. Number 45. 47. Swan Auto charges $32 a day plus 18 cents a mile. Elaine rented a car for 1 day. She drove 83 miles. How much did she pay? And then Ramon paid to rent a car. How far did he drive? We need an equation. What is your equation? Y equals what?
32 plus
0.18x
plus 32.
plus 32.
So that was just 7.
Where x is the miles and y is the cost. Every mile costs me 18 cents. No matter what, I gotta pay $32 just to get off the line. So, how much did she pay? She rented it for
20.
83 miles. That's how much she paid, right? $46.94. Ramon paid $69.80 to rent the car for 1 day. And we wanna know how many miles he drove it? Yep, so we set our equation equal to $69.80. I think he drove 210 miles, what do you think?
I think so. Alright, so is everybody good on our equation? Every mile costs 18 cents. Plus the 32 you're gonna pay no matter what. Alright, you guys have a lot of energy with your partner.
Number 2, solve these two equations, A and B. Solve the two equations in A and B.
Negative x squared plus negative x squared b equals 0. Yeah, I am taking this side. Okay, so next formula x squared it's just like 9 plus. Yeah, over 2b or 2x. What? 12? It actually goes 6 and negative 2. What do you mean plus 12? There's no plus. Okay. You do these times each other first. Not negative 14. And then on B, we're going to do the quadratic formula because you can't you're literally thinking about a watch. You do it. You do it your way. Boom. All in and I cook. It's 49 plus 56. Yeah. What you get? 6 negative 2. No. Negative 6. No. We're down for 6. I'm not about negative 2. Come on. Some of us I was thinking it was negative 49. You think I'm running about you like back into that. Oh no, I think you want
Alright, did you guys get the first one, the factor? Did anybody use the quadratic formula on the first one?
No.
Okay, did you get the same answers?
We did. Yeah.
Now, the quadratic formula is going to require some simplifying to get down to 6 and negative 2, but yes, absolutely. I couldn't factor this one, so I did the quadratic formula. 105 does not break down because 105 is 5 times 21. So 105 doesn't have any pairs, so we'll stick to 105. Anybody have a question about that? Please practice, guys, because some of you didn't do so well on your test. You need to fix that. Some of us did well. All right, number 3, we're going to solve graphically with our calculator. So in other words, we're going to graph this thing. Thank goodness, because that would be awful to try to solve. So I'm going to go to y equals, and put that in. And then I'm going to do y2 equals, and put that in. I'm going to zoom 6 just to make sure I'm set up right. And then I'm going to find their intersection, second
calculator said, I should see a calculator and everybody can. We should all be practicing. Can't really give any partial credit for this, so let's make sure we know what we're doing.
Good looking graph.
Very good.
It's like a wave.
Yeah,
There'll be two pictures, they're not lines. Yeah.
So they just like
This is it.
Yeah.
second match.
So if you type this in as Y1 and this is Y2, you want to know where they cross each other. How many got 2.665? All right, how many are still working on it? All right, keep going.
Once you get the graph, what's your next step?
Second, count intersect. You should. All right, if you finish that one, you got 2.665, go ahead and do the next one. You guys both get 2.665. You guys get 2.665.
copied me,
She ended up.
Girls, you get 2.665. 2.665 over here. Jamie's calculating.
Be like. Go. Left, go. Forward. Come on!
Close doesn't count.
Shut up. It was actually just fun.
Dude, Finn, it was the funniest thing. He like kept saying like we just leave. Like we got back from my age circle with us. We were like wanted multiple orders. And she like put it all on one and Juan was about to pay like $35 for all of food. And he's like, wait, what? And then she made him do it all over again. We were at Jim's for like 30
Oh, you were at the store?
like in the drive-thru. And we were just like
What? How are you so like? Your calculator does it for you. Brandon can't get it right with using calculator.
Good, bro. Why is your face always so red in this class?
It's open with real ones already have
Yeah, Lonnie. It was the most random group of people I've ever been around in my life.
Where?
Early brown.
We were getting glued. What?
Like 40 people there.
Wait, how did I not?
Dude, Finn, you know, just passed out on his couch and his mom comes downstairs.
Who?
Then we go outside and there's
Bro, she was already
You guys got 2.665.
the bears come back and eat that shit.
Okay, you guys get 2.665? All right, I haven't done this one. What did you get for this one?
Negative 1.372.
Negative 1.372?
Yeah. And then
I didn't
4 point,
check
and then 4.372.
Okay, two answers.
What?
4.372. Can somebody explain why there are two answers? That's a parabola, and that's a line. And in most situations, they're not all, but in most situations, they are gonna cross in All right, 1.1 is due on Thursday. 1.1 is due on Thursday.
1.2 is a long same.
Yeah, 1.2 is big. But we're gonna start down to right now.
Whoa. Wow.
So you just put it in.
You can put it in as one equation. But if you put it in as one equation, you're not gonna second calc intersect, you're gonna second calc zero. Right?
I did it.
Now your answer should not be this decimal. So if you find your radical answer, type them in. All right, now, a big part of your calculus experience is going to be this idea of functions being continuous. In, like, layman's terms, if I were just explaining this on the most basic level, continuous means that whatever shape you've got, you can draw the whole thing without lifting your pencil. It's one continuous flow. Now, it might be, random shape or whatever, but it's all one piece. So an example of a continuous function would be like your parabola. That is a continuous function because you can draw the whole thing without lifting your pencil. Okay? Another continuous function would be like the cubing curve. That is a cubing curve. That's a continuous function. Now, a removable discontinuity is a issue that we can remove from the problem. So, for example, if you had this problem, x cannot be 1. Would you agree with me? Because what happens if x is 1? You have a 0 in the bottom and you can't have a 0 in the bottom. So, if you look carefully though, you will notice that you can factor the top, and what will happen after you factor the top? These will cancel, and you no longer have the issue, right? Now, that is called a removable discontinuity because you removed the issue. The issue was x can't be 1. That means you couldn't draw the whole thing because you can't draw at 1. When you have a removable discontinuity, you can go ahead and put 1 in and get 2, but it's an open dot in the picture. So a removable discontinuity is a hole. It's a hole in the graph. It's still a discontinuity. It still makes me lift my pencil, but it's not as serious as the non-removals. So if you can factor and cancel, you're going to have a hole in your picture. Okay? If you can factor and cancel, you'll have a hole. A jump discontinuity you have seen before. Do you remember from last year your good friend, the greatest integer function, sometimes called a step function? That's a jump discontinuity. Because I draw a piece, and then I jump up, draw another piece, jump up, draw another piece. There are 3 kinds of discontinuities. There's this kind that you just cancel out, it's gone, but it stays as a whole. There's a jump where the nature of the function itself causes you to take steps. And then finally, there's a non-removable discontinuity. So if we had this, would you agree that x can't be 1? Would you agree there's no way I'm gonna cancel that out? So it is a vertical asymptote at x equals 1. That is called a non-removable or infinite discontinuity, and that's the most serious kind. That literally breaks your picture into 2 pieces. It's called a vertical asymptote. The word asymptote has a P in it, but please don't say the P. It's asymptote. There's no P sounded. Okay? And a vertical asymptote, well, vertical means vertical, but an asymptote is a line that the curve will get closer to, but never touch. So as it comes this way, it has to go up, up, up. Then I gotta pick my pencil up and start the next piece. 2 separate pieces of picture with an infinite or non-removable discontinuity. So while we're talking about asymptotes, I'll share my little story. I have lots of stories. I'll share my asymptote story with you. So back in like 08, 07, 09, back in that time, I had a group of kids. They were really excited about math week t-shirts. They put one together and the school wouldn't approve it. They shot it down, said it wasn't appropriate. So the kids, the great kids, but they got a little frustrated. So they had these shirts made anyway, just for that class. And on the last day of school, they wore them, and they gave me one, which I still have. It was black with white writing. And you know that old got milk thing, you know, with the big question mark, got milk with the big, okay, that's what it said on the front, got math. And then on the back it said, you bet your asymptotes. I thought it was adorable, but and usually I'm like a buddy buddy, but they didn't approve it. But I have one, I have one.
Clever though.
All right. All right, here we go. Now, I am going to rely on you remembering something from last year. I know that's a questionable assumption on my part, but this is an absolute value graph. What do they look like? Very good. Oh, dang, it's all over. I said, oh, Michael was doing it too. Okay, so we have a V. Absolute value V. All right? Now, the normal absolute value, V's from the origin. This one has been moved. These numbers move it. It's called the translation. It's been moved. Anybody take a guess how it moves?
Down one. Down one.
Down 1, absolutely. So it's down 1.
Right 2.
Right 2. So this, or no, left.
Left 2, sorry, that's something that's
You mean that?
Left down 1. This is a plus, so it goes left. Left 2, down 1. And there's my V. All right? There's the picture. That's all you need, all right? Nothing else. I got a V, and it's being from left 2 down 1. Now answer the questions. Would you say that is a continuous function? Yes. Because, don't worry about the arrows. The whole thing can be drawn without lifting your pencil. Would you say it is increasing or decreasing?
Increasing.
That Actually, it's both. Because on this side of it, it's decreasing from negative infinity to negative 2. This part of it's decreasing. And we're talking about x values now. X values. And then it's increasing from negative 2 to infinity. So starting here, it's increasing. Getting to here, it is decreasing. Would you agree? Now, this guy, on the other hand, this guy is only increasing, right? Increasing. Left to right, going up. Bounded above, below, and bounded. This is calculus vocabulary. Bounded above means it has a ceiling. Does this curve have a ceiling?
Nope.
So it's not bounded above? No. Bounded above? No.
No.
Nope.
Bounded below means it has a floor.
Floor.
Four, yes.
Does this have a floor?
Yes.
Yes.
Yes, and where is the floor? It is at -1. So it is bounded below at -1. Its floor is at -1. If you have a curve that has a ceiling and a floor, it's called bounded. This one is not bounded. It's not bounded above, it is bounded below, not both, so it's not bounded. Okay? A handy dandy sine curve would be bounded because it has a ceiling and a
Floor.
all right, hurry, let's get this done. Asymptotes. Does anybody have any asymptotes? No asymptotes.
No.
Asymptotes are lines that we approach and don't intersect. There is nothing controlling this curve. It's gonna go forever. All right, we'll finish the rest tomorrow. All right, have a good lunch. I'll see you guys tomorrow. Yeah, you're welcome. Yeah, have a good day. Go light the world, you guys.